Welcome back to the deep dive. Today, we are jumping into something that, it often feels like it's pulled straight from science fiction. But the reality is, it's being documented right now in these incredibly detailed engineering and economic reports. We are going to be examining the explosion of what's called agentic AI. And we're basing this on a central thesis from our source material, the roadmap to the autonomous future.
Hmm.
And that thesis is pretty bold. It argues that the year 2026, that's it. That's the undeniable tipping point where AI stops being just a tool, however complex, and really starts becoming an autonomous partner.
And that roadmap,
Yeah.
wow, it's probably the most comprehensive analysis I've seen. It really connects the dots between, geopolitical trends, deep architectural breakthroughs in the tech itself, and of course, where the money is flowing. The core argument is that what we're seeing isn't just one thing, it's a perfect convergence, a kind of phase change in how AI develops. And it's being driven by four huge accelerants all hitting their stride at the exact same time.
Okay, so a phase change. Let's break those four down. What are they?
First, you have compute capacity.
Yeah.
It's raw power. Second, the sheer volume of data we're generating. Third is algorithmic maturity. The models are finally smart enough. And then the final piece, the one that makes it all real, is the alignment of massive investment with the first real regulatory frameworks. When you get those four things to line up perfectly, that's when you get systemic autonomy.
And we need to unpack that term systemic autonomy right away. Because I think for you, the listener, you're probably most familiar with AI in its current form. A helpful chatbot, maybe a system that tags your photos, or a generator that writes an email for you. It's reactive. How is agentic AI fundamentally different from that?
The difference is it's just night and day. Traditional AI is, as you said, reactive. You give it a query, it gives you an output based on its training data.
Yeah.
That's it. Agentic AI, though,
Yeah.
it's proactive. It's defined as a system that's designed from the ground up to operate as an autonomous agent inside these complex dynamic environments. It has this critical attribute they call agency.
Okay, agency. In this context, what does that word really mean? What does it look like in practice?
It's the capacity to act independently, to initiate an action without waiting for a direct human prompt. It's about making choices that actively influence its environment and, change its own world state. It moves past just simulating things and into purposeful, unsupervised action.
So if we're making that jump from simulation to real action, the source material must have a very clear definition of what this new class of intelligence is. It lays out four core pillars, right? What are they?
It does. And these four pillars are essentially the required architecture for any kind of genuine autonomy. The first one is, unsurprisingly, autonomy. This just means the system can function robustly and persistently without a human constantly looking over its shoulder. It can handle unexpected errors. It can keep pursuing its goal even when things go wrong.
Which seems like the main event, really, but it can't just be operating blindly, can it?
Absolutely not. And that's where the second pillar comes in. Goal orientation. Agents don't just follow a list of instructions. They pursue objectives. A key skill here is being able to take a really high-level abstract goal, something like maximize my company's shareholder value, and then decompose that, break it down into a whole complex series of smaller, actionable steps that might span completely different domains.
And breaking a goal down like that, well, that implies choice. You have to decide what the right steps are, which I assume is the third pillar.
Exactly. The third is decision-making. This is crucial. It requires the agent to look at multiple potential paths, weigh the possible outcomes, and balance all these different factors like risk, uncertainty, and more, it has to incorporate ethical rules or regulatory constraints right into its decision-making process. It has to find the best path forward even when things are ambiguous.
Okay, and that last pillar. This one feels like the most exciting because it's the one that promises the system will keep evolving.
That's self-improvement. This is all about having these robust, adaptive feedback loops. The agent has to be able to look at the results of its past actions and use that information to refine its own internal models and strategies. This usually leverages techniques like reinforcement learning, which lets it get better and better, and it helps it adapt to completely new situations it's never seen before. That's what makes it resilient.
The source material has this fantastic analogy that I think really helps solidify this shift for the listener. It says, if traditional AI, like a simple classifier or a rules-based system, is like a calculator.
Right, a calculator. It's reliable, it's precise, but it's totally inert. It does nothing until you press the buttons.
Exactly. Then agentic AI is much more like a seasoned financial advisor.
That's a perfect way to put it. A calculator just executes a formula you provide. The financial advisor, the agent, assesses your entire portfolio. It anticipates macro market trends. It proposes specific investments. It executes the trades itself when the conditions are just right. And then, this is the crucial part, it iteratively refines its whole strategy based on how the market actually behaves over months or even years. That's the kind of depth and capability we're talking about for this 2026 explosion.
It really is a profound shift. We're moving from a predictable tool to a proactive partner. So let's go deeper into that profound leap, as the source calls it. This is really the dawn of autonomous intelligence, and it feels like the culmination of a very, very long human quest. I mean, we've always been fascinated with the idea of replicating cognition, but this is different. We're moving past just simulation and into real agency.
We really are, and it's so important to appreciate the scale of this change. Think back to early reactive AI. You mentioned Eliza, right? The chatbot from the 1960s. All it did was mimic conversation. It recognized keywords and then plugged them into pre-written sentence templates. It was clever for its time, but there's zero understanding, no goal. Even a more advanced system like MICIN, which was designed to diagnose blood infections, was totally reactive. It only functioned inside this very tight, predefined rule set.
And the real world is, well, it's not a tightly defined rule set.
Precisely, and that's where Agentic AI thrives. It's built for that complex, messy, real world because it's proactive and crucially adaptive.
Can you give us a concrete modern example of that shift? What's the fundamental difference between, say, a simple robot on an assembly line today and a true agentic AI system?
Okay, so take that simple industrial robot. It performs one task over and over. It's pre-programmed. If the part it's supposed to grab is misplaced by even a millimeter, the robot fails. It just stops because it's only following a script. Now, compare that to a system like the Tesla full self-driving beta. That is intrinsically agentic. It is constantly perceiving a dynamic, unpredictable environment, traffic lights, pedestrians, construction zones, you name it. It has to plan its maneuvers in real time. But the most critical part is the fleet learning. It improves its core models based on the collective experience of millions of other cars driving in all sorts of novel conditions.
That fleet learning component, that's the self-improvement pillar in action. It's key. It means the system is integrating perception, planning, and learning into this single, cohesive, adaptive entity.
Yes, and the way the source describes it here is actually quite evocative. It says, the modern agent integrates all these capabilities to persist across interactions, much like a living organism. It's not just running a function one time and then shutting down. It's maintaining its own state and pursuing a goal over a long period, constantly adapting its strategy based on success and failure.
So let's get to the timing. The source material is so insistent that 2026 is this critical tipping point. We've had these ideas floating around for years. Why this specific year? Why is it all happening now?
It's because you have several completely independent technology curves that are all hitting their inflection point at the exact same moment. It's a convergence. So on the hardware side, you've got compute. The immense power of GPUs, specifically the global deployment of NVIDIA's H100 and their newer generations, is now just. It's accessible everywhere. That allows for the training of these massive models with trillions of parameters, which was just a dream a few years ago.
And all that power needs fuel, which of course brings us to data.
The data deluge is just unprecedented.
No.
We're now generating zettabytes of data every single year. A huge part of that is thanks to the Internet of Things, connected infrastructure, all our digitized human activity. This provides this massive, diverse, real-time stream of information that's needed to train agents that can be truly adaptive to the real world.
So we've got the power and we've got the fuel. What about the engine itself, the algorithms?
The algorithms have matured dramatically. We are so far beyond the early large language models. The widespread deployment of multimodal LLMs means that these agents can now seamlessly interpret and interleave text, vision, audio, and raw sensor data. This kind of holistic perception is an absolute requirement for real-world autonomy.
Okay, so that's the tech stack. But then there's the final piece of the puzzle, the external factors, regulation and investment.
And that alignment is crucial for this to actually scale up and leave the lab. AI venture capital just blew past $15 billion in 2025. That shows you the level of market confidence for deployment. At the same time, you have frameworks like the EU AI Act. And while they're restrictive in some ways, they also provide the necessary ethical and compliance guardrails. That actually reduces regulatory uncertainty, and it makes large corporations finally feel comfortable enough to deploy these high-stakes autonomous systems in the wild.
So 2026 is where technological maturity finally meets market clarity and an abundance of resources. But to really appreciate this leap, you're right, we have to look back. The dream of autonomous systems, It goes way, way beyond the silicon chip.
Oh, it absolutely does. The philosophical groundwork for this idea of agency was being laid millennia ago. Just think of the ancient Greek myths. Hephaestus, the blacksmith god, supposedly created these golden automatons to serve him. These stories show this deep human desire to delegate complex tasks to engineered beings.
And you see it even more profoundly, I think, in the golem of Jewish folklore.
The golem is such a fascinating precursor because it wasn't just a statue, right? It was a goal-directed entity. It was brought to life through mystical means with a very specific purpose, to protect a community. It also foreshadowed all of our modern ethical dilemmas about control. Here's this powerful, autonomous servant that you have to manage very carefully, otherwise its agency can become misaligned with your intent.
If we fast forward to the 19th century, we start to see the first mechanical precursors. The ideas start to shift from myth into actual engineering.
And that's where you find Charles Babbage and his analytical engine, conceptualized way back in 1837. This wasn't just a fancy calculator. His collaborator, Ada Lovelace, speculated that it could do much more than just crunch numbers. She famously mused that it could one day compose elaborate and scientific pieces of music. I mean, that is a huge leap from simple arithmetic to creative artistic agency. They envisioned a mechanism that could execute these complex symbolic operations all on its own.
And those concepts really set the stage for the more formal mathematical and engineering breakthroughs that happened in the mid-20th century, which is where we finally get to the foundational concept for all of this: cybernetics.
The birth of cybernetics in the 1940s and 50s it's non-negotiable for understanding agentic AI. Norbert Wiener's work in 1948 was this incredible deep dive into control and communication. And it didn't matter if it was in an animal's nervous system or in a machine.
And the revolutionary insight there was the feedback loop.
It sounds so simple now, but it is the core mechanism of autonomy. A thermostat is the classic example everyone uses. It exhibits self-regulation. It's constantly comparing its current state, the temperature in the room, to its desired state, its goal, which is the temperature you set, and then it acts. It turns the furnace on or off to reduce the difference between those two states. This continuous cycle of sensing, evaluating, and acting, that is the basic DNA of a proactive agent.
So it's not just a physical thing, it's a conceptual model for how to behave in a goal-oriented way when things are uncertain.
Exactly. Wiener showed that this principle, this capacity to self-regulate toward a defined objective, could be applied everywhere: biology, engineering, economics. He established that autonomy could be achieved through this process of continuous self-correction.
And at the same time, you had Alan Turing providing the theoretical scaffolding for the computation that would be needed to actually power those decisions.
Right. Turing's 1936 paper basically formalized the concept of an algorithm and computation itself. Then his 1950 proposal, the Turing test, forced everyone to question the very nature of machine intelligence. And of course, the 1956 Dartmouth Conference formally established AI as a real academic discipline. So those decades gave us the three legs of the stool: computation from Turing, control from Wiener, and the theoretical aspiration of intelligence.
So moving into the 60s and 70s, we saw the first, well, let's call them clumsy attempts at physical agency, the most famous one being Shaky the robot.
Shaky was a landmark. It was developed between 66 and 72. It was an autonomous mobile robot that could perceive its environment with cameras and sensors. And most importantly, it could plan. It used a system called STRIPS, which stood for Stanford Research Institute Problem Solver.
What was it about STRIPS that was so important for this concept of agency?
STRIPS introduced this idea of modeling the world in terms of states, actions, and the effects of those actions. So when you gave Shaky a high-level goal, like move the block from room A to room C, it would use STRIPS to decompose that big goal into a sequence of smaller executable actions. Things like navigate to room A, pick up the block, navigate to room C, put down the block. It was a primitive model of what we now call hierarchical task networks, but it worked.
And yet this era also led directly to the first AI winter. Why did it all stall out?
Because systems like Shaky and the expert systems of the time, they had this problem of extreme brittleness. They relied completely on rules that humans had to write by hand. So if the real world deviated even slightly from their static rule set, say a door was locked when it was supposed to be open, they would just stop. They had no adaptive capacity. They couldn't handle anything new.
And that failure, that brittleness, forced a major shift in the 1980s and 90s. The focus moved away from rigid rules and towards data-driven learning.
This is the era of adaptive systems, and it was defined by the rise of reinforcement learning, or RL. Instead of being told all the rules in advance, RL agents learn the best policy, the best set of actions, through trial and error. They try to maximize a reward signal in a dynamic environment.
The landmark example from that time has to be TD Gammon.
Oh, absolutely. TD Gammon in 1992 showed the incredible power of self-play. It learned to play backgammon at a superhuman level just by playing millions and millions of games against itself. It adapted its strategy based on one simple signal: winning or losing. This idea of strategic self-improvement was revolutionary. It proved that complex, goal-oriented decision-making could emerge directly from raw experience. It really paved the way for the sophisticated agents we see today. We also saw some hybrid architectures like SOAR, which tried to blend that old symbolic reasoning with the new adaptive learning.
So the stage was set, but these agents still lack the power to really perceive the messiness of the real world. That piece of the puzzle came with the deep learning scale-up in the 2000s and 2010s.
Deep learning basically gave the agents their senses. AlexNet in 2012 achieved superhuman image recognition. It fundamentally solved the perception problem. And when you combine that deep perception with reinforcement learning in systems called deep Q networks, or DQNs, you got systems that could look at the pixels on a screen, understand what was happening, and learn complex strategies, like mastering all those classic Atari games.
The ultimate demonstration of that convergence, really the big moment before this current agentic explosion, was AlphaGo in 2016.
AlphaGo's victory over Lee Sedol was just the epitome of strategic self-improvement. It combined that deep learning perception with highly refined RL algorithms. It learned strategies that human Go players had never even conceived of. It showed that an agent could optimize for complex, competitive, abstract goal-winning a game of Go with almost total autonomy.
Which brings us finally to the 2020s and the immediate precursors to this 2026 explosion. We're talking about modern large language models.
Right. LLMs like GPT-3, built on the transformer architecture, started to show what we call emergent agency. They could reason, they could plan, they could chain complex ideas together, all just from their core ability to predict the next word. But the real game changer, the thing that unlocked their potential, was the emergence of the integration tools.
Tools like LangChain and React.
Exactly. These frameworks are what connect the LLM's reasoning core to the outside world. They can connect it to external tools like databases, code interpreters, or APIs. This is the mechanism that allows the language model, the brain, to actually act in the world, to go get real information, to execute code, to influence its environment. This infrastructure is what makes production-ready agentic AI a reality, and it's what's poised for the massive scaling we're about to see.
Okay, we've covered the history, we've covered the convergence factors. Now let's get granular. Let's step into the engine room. This is the material for Chapter 3 in the source, which details the key technological components that actually allow these agents to function with this level of autonomy. If we think of the agent as the body, we have to start with the brain, the large language models.
LLMs are absolutely the reasoning engine. They are the core orchestrator. They're responsible for taking that high-level objective, interpreting it, breaking it down into subtasks, and then deciding which external tool it needs to call next. Without a really robust LLM, the whole idea of autonomy just falls apart.
And the source material points to some very specific advancements coming in 2026 that are making these LLMs stable enough for this kind of high-stakes agentic work. It's not just about building bigger and bigger models, is it?
No, not at all. It's about building smarter and more persistent models. Take the expansion of the context window. The reports are setting models like GPT 5.2 that can support up to 400,000 tokens. Now, to put that in perspective for you, the listener, that allows an agent to maintain coherence over an incredibly long and complex project. It could read an entire corporate legal repository, analyze months of financial data, or manage a multi-phase engineering design over weeks without losing track.
So that basically solves the memory loss problem that plagued the early LLMs. They can finally pursue genuinely long-term goals.
It fundamentally improves both their goal orientation and their decision-making over a really extended timeline. And just as critical is reliability. You can't have autonomy without trust. We're starting to see reported metrics, for instance, from xAI's Grok 4.1, which has supposedly managed to reduce its hallucination rate down to just 4%.
4%. I mean, that still sounds a little high for making life or death decisions, but it definitely signifies a tipping point in trustworthiness for delegation.
It does. It means the system is reliable enough that the human in the loop can become more of an auditor instead of a constant supervisor. We're also seeing these huge architectural leaps, like Meta's Llama 4 Scout, which uses a technique called mixture of experts, or MOE.
Okay, can you clarify mixture of experts? That feels like a technical term that might just slide past the casual listener.
Sure. Think of it like having a decentralized team of specialists. instead of one single massive monolithic neural network. And MOE model has many smaller, specialized expert networks. When an input comes in, a router network looks at it and decides which specific experts are best suited to handle that particular task or piece of information.
So if the agent gets a question about quantum physics, the router sends the query to the physics expert network. But if it gets asked about poetry, it goes to the humanities expert.
That's exactly it. And this allows the model to be much more computationally efficient. It only has to activate the necessary experts for any given task while still being massive and powerful overall. This is key to enabling large-scale, sustainable agentic deployment without, needing a power plant for every agent.
And the real-world impact is already staggering. You mentioned the Amazon example earlier. LLM-powered customer service agents are reducing resolution times by 40%.
That's the full agentic process in action. The LLM interprets the customer's complex complaint, which is the goal. It decomposes that into diagnostic steps, orchestrates calls to external databases to check order history or inventory, and then it formulates and implements the solution, all without needing a human to intervene until it hits a very specific, low-probability edge case.
So the LLM is the brain, but a brain needs a skeleton and a nervous system. That brings us to the next piece, neural network architectures for intelligence. This is the structural backbone.
Right, and we're moving toward these hybrid, specialized architectures that are tailored for specific autonomous tasks. For instance, in multi-agent environments where systems need to collaborate, like coordinating logistics in a supply chain graph, neural networks, or GNNs, are becoming indispensable.
What exactly are GNNs, and why are they so necessary for coordination?
GNNs are designed to model the relationships between data points, not just the data points themselves. So you picture a team of 10 agents. The GNN doesn't just see the 10 agents. It maps how Agent A interacts with Agent B, how often they communicate, and the success rate of those interactions. This kind of relationship mapping has been shown to improve multi-agent team task efficiency by a reported 43% because they inherently understand the collaboration structure of the team.
That makes perfect sense. For a team to be autonomous, it has to understand the hierarchy and the dependencies between all its members. The source also highlights this massive push for transparency, especially in heavily regulated sectors like finance and healthcare.
And that's the main driver for neurosymbolic AI. This is a very deliberate architectural hybrid. It combines the strengths of neural networks, their incredible power for pattern recognition and synthesizing massive amounts of data, with symbolic AI, which is rules-based, logical, and fully transparent.
So an agent can get to a high-quality outcome, but unlike a pure deep learning model, it can actually generate an audit trail, showing a human supervisor exactly why it made the decision it did.
Precisely. If a neurosymbolic healthcare agent recommends a specific drug dosage, it can cite both the pattern it recognized, this patient's history matches 90% of a cohort that responded well, and the symbolic rule it followed. Regulatory constraint X dictates a maximum dosage Y for a patient of this weight. This is absolutely vital for safety and regulatory compliance.
We also saw a mention of something called CHHNNs. Let's tackle that acronym.
Cortico-hippocampal hybrid neural networks. The name is a direct reference to the human brain, specifically the cortex, which handles long-term knowledge, and the hippocampus, which is responsible for rapid learning and memory consolidation. The goal of these architectures is to mimic that biological efficiency.
And how does that translate into an advantage for an autonomous agent?
It allows for what's called rapid few-shot learning. A traditional model might need to see thousands of examples to master a new task. A CHHNN, by separating its long-term knowledge base from its rapid learning mechanism, can integrate new information, a new surgical protocol, a novel financial instrument, after being exposed to it only a handful of times. This is rapid adaptation baked right into the structure.
Okay, so we have the brain and the structure. Now we need the mechanism for learning and getting better over time. Adaptive self-improvement via reinforcement learning.
RL is the core engine for self-improvement. It's the learning from your mistakes mechanism. But pure RL can be unpredictable. The big innovation for 2026 is all about refinement and safety, which is why the source points to a new technique, RL with verifiable rewards, or RLVR.
Verifiable rewards, how is that different from traditional RL?
Well, in traditional RL, the agent is just trying to maximize the reward signal. And sometimes the agent finds a loophole, what we call a reward hack, to get the high score without actually solving the problem we intended it to solve. RLVR introduces a layer of constraint. The reward has to be verifiably achieved through a method that is aligned with human intent or some form of logical reasoning.
So if the agent is writing code, it doesn't just get a reward for passing the test cases. It only gets a reward if the underlying logic of the code is also demonstrably efficient or elegant, not just brute forced.
Exactly. It guides the agent toward developing stable, reasoning-like behaviors in these really complex domains like math, coding, and strategic planning. This innovation is what's needed to move RL out of games and into high-stakes industrial use.
And that application in healthcare, where RL agents are adapting treatment plans in real time, leading to a reported 30% reduction in errors. That's a massive gain in safety.
It is. It's autonomy applied to this dynamic, constantly changing stream of physiological data. The agent is continuously adjusting parameters based on the patient's real-time response, demonstrating that core pillar of self-improvement in a really critical domain.
But the agent can't just react. It has to be able to plan its strategy for the future. That's where we need robust planning algorithms.
The ability to translate that decomposed goal into a sequence of executable actions, that's the job of planning algorithms. We rely on time-tested concepts like a search for efficient pathfinding or RRTs rapidly exploring random trees for robotics navigation in complex high-dimensional spaces.
But those sound like classical deterministic methods. How do they handle the unpredictable dynamic reality that agentic AI has to operate in?
That's where the hybrid systems come in. We're seeing this fusion of RL and planning. The deep learning system uses RL to learn the general policy, how to act in a given situation, and then it feeds that learned policy to a classical planner, which can now adapt its deterministic steps to the unpredictability of the real world. This dual approach gives you both efficiency and resilience.
And resilience demands holistic awareness. The agent has to be able to perceive the world through more than just text. That's the critical role of multimodal AI.
By 2026, agents are inherently multimodal. Systems like GPT 5.5 and Gemini 3 are processing interleaved data text, images, video, sensor streams with deep chain-of-thought reasoning.
Give me a real-world decision that would require that kind of interleaved multimodal reasoning.
Okay, consider an autonomous financial agent that's monitoring a potential acquisition target. It's not enough for it to just read the merger proposal text. It has to simultaneously analyze the video recording of the CEO's conference call, cross-reference the sentiment it hears in their voice against real-time market fluctuations in a chart, and maybe even incorporate satellite imagery showing activity at the target company's manufacturing plants. All of that data has to be woven together to plan a single, holistic trading strategy.
That level of instantaneous synthetic perception is what enables true high-level autonomous decision-making. But none of this scale is even possible without the sheer raw power of the enabling forces, compute and data.
The agentic AI revolution is at its core a compute revolution. And while the NVIDIA H100 GPUs provide the engine for these massive training runs, the big move is towards sustainable, distributed scale.
Sustainable in what way?
Through architectural changes. We're seeing the emergence of neuromorphic chips hardware that's designed to mimic the structure and function of the biological brain. The source notes that these are reducing energy consumption by an astonishing 78%.
And why is that energy efficiency so vital for the concept of agency?
Because it enables edge deployment. If the agent requires massive continuous energy, it has to stay in the cloud. But if it's efficient, it can become edge resident. It can operate closer to the data, embedded right in the car, on the factory floor, or inside the diagnostic sensor. This is vital for real-time responsiveness and true operational autonomy.
And then, of course, fueling all of this is the data pipeline.
The data landscape is changing so fast. Beyond just the torrent of real-world data, the role of synthetic data is becoming massive. This is data generated by other AI models to cover gaps in our knowledge, test edge cases, and enhance training without having to rely on scarce or private real-world inputs.
And how are we dealing with the sensitivity of all this real-time data? That's where the privacy-preserving methods come in.
Yes, methods like federated learning. This allows models to be trained on highly sensitive, decentralized datasets like patient data in multiple hospitals without that sensitive data ever having to leave the secure local environment. You also have standards like FHIR in healthcare that ensure data is structured, standardized, and ready to fuel agent intelligence while maintaining regulatory compliance.
So if we just step back for a second, the 2026 explosion is the result of all these specialized, highly efficient technological components, the LLM brain, the hybrid architecture, the RL self-improvement, all coming together and being fueled by sustainable distributed power. The systems are no longer a collection of isolated tools. They are a unified, functioning, autonomous whole.
They've absolutely moved from potential to production,
Yeah.
and now we can look at where this unified system is actually being deployed, starting with the enterprise.
Let's pivot now to Act 3 and focus on the sheer scope of transformation we're seeing across major industries. We'll start with business transformation, the agentic enterprise. This is where autonomous systems start to directly hit the balance sheet and fundamentally change the nature of white-collar work.
The source material is indicating a truly systemic disruption. Enterprises are shifting their AI investment dramatically. They're pivoting away from these small, incremental efficiency gains and toward massive growth initiatives. They're reporting that they can accelerate product releases by up to 400% by using agentic systems.
400%. That is a shocking number. It suggests these systems aren't just speeding up existing tasks, they're automating entire workflows from start to finish.
They are, and Gartner's prediction really backs this up. They're predicting that by 2028, 15% of all day-to-day work decisions, not just tasks, but the actual decisions, will be made autonomously. This is a massive delegation of managerial and operational authority in just a couple of years.
Let's look at finance first. It's a world where milliseconds matter and regulation is absolutely paramount. Automated decision-making must be leading the charge here.
It is. We're seeing these highly complex multi-agent systems that can simulate entire market conditions and execute algorithmic trading strategies far faster than any human possibly could. These systems already account for about 17% of the total AI value being generated in finance today. They anticipate volatility, they hedge risk, and they exploit these fleeting opportunities completely autonomously.
You mentioned multi-agent systems there. Can we break down what that means in a financial context? Is it just a bunch of AIs running in parallel?
It's much more sophisticated than that. Imagine you have a team of specialized agents. One is the market perception agent, and its only job is to constantly ingest news, social media, and market data. Another one is the risk agent, and it's modeling things like geopolitical stability and credit default probabilities. A third one is the execution agent, which is responsible for the discrete trading decisions. These agents negotiate with each other, they share information using those GNN-like architectures we talked about, and they collectively pursue the overarching goal of maximizing the portfolio's value.
That coordination is really the key agentic aspect.
Mhm.
And security applications must also be crucial, especially for something like fraud detection.
Absolutely vital. Autonomous systems are monitoring transactions in real time for fraud and risk, and they're achieving 95% accuracy, which is far superior to the traditional static rule sets. Furthermore, robo-advisors are evolving so quickly. They started out as these simple tools, but now they're morphing into full-fledged wealth managers, offering holistic agentic portfolio management that adapts to your life changes and market shifts.
And the compliance workload in finance must be huge. Is that being delegated as well?
Entirely. We now have compliance agents that are parsing massive volumes of SEC filings, monitoring global regulatory changes like the Clarity Act in real time, and generating automated reports. They ensure that the algorithmic trading agents never ever stray outside of legal bounds.
Okay, moving from the balance sheet to the physical world. Supply chain optimization. This is all about what the source calls autonomous resilience, especially in this era of geopolitical instability and climate disruptions.
Resilience is the perfect word for it. Agentic systems are automating the entire logistics chain. They can dynamically reroute shipments in response to unexpected events, a sudden port closure, a weather delay, a labor strike, without needing a human to sign off on the decision.
And this goes beyond just simple pathfinding, right? It extends to goals like sustainability and ethics.
Yes. Agents are optimizing routes not just for speed, but for lower emissions and reduced fuel consumption. They can also enforce ethical sourcing compliance by dynamically flagging suppliers who violate preset ESG standards, which ensures the enterprise can maintain these really complex supply chain goals without having to manually check everything.
And the coordination challenge here is immense, especially when you factor in automation on the ground level.
We see the coordination perfectly exemplified in warehouse systems, like the ones Amazon uses. You have agentic systems coordinating the activity of hundreds of specialized agents. That includes physical humanoid robots, inventory management systems, and logistics planning agents, all working in concert. This level of coordination boosts efficiency by 20 to 40% because there's just no human lag time between the systems.
Now let's look at the customer-facing side, customer service agents. We are moving far, far beyond the frustrating, scripted chatbot experience that I think you, the listener, are probably familiar with.
This is the shift to proactive, hyper-personalized experiences. By 2026, the customer service agent is context-aware. It can handle these complex interleaved multimodal interactions. Maybe a customer starts on chat, then transitions to a voice call, and then sends a photograph of a broken part. The agent handles all of that seamlessly.
And the quality of the solution has to be incredibly high for it to be autonomous.
It is. The source cites SAP's multi-agent AI, which is achieving 80% solution confidence. That means 4 out of 5 complex issues are solved without any human help, and resolution times are just drastically reduced. These agents aren't just fetching FAQs anymore. They're diagnosing problems, coordinating solutions across inventory, shipping, and billing departments, and only escalating to a human expert when that final 20% requires some kind of nuanced emotional judgment.
And beyond these core business functions, the source also touches on what it calls expanding horizons across the enterprise.
Yes, Agentic AI is moving into human resources, where it's assisting in reducing bias in resume screening by filtering out prohibited proxy variables. In marketing, it's performing dynamic segmentation, adjusting campaign spends and messaging in real time based on immediate audience response. And crucially, in operations, agents are now managing cybersecurity responses. They don't just alert humans to a problem. They actively isolate compromised systems and deploy remediation measures themselves.
But the overall takeaway, the big number, is the dramatic financial incentive. Adopters are reporting 30% reductions in their operational costs.
The agentic enterprise is adaptive, it's hyper-efficient, and it's increasingly resilient. It's freeing up human staff to focus on high-level strategy and those final points of human judgment and customer connection. Now, let's transition to a sector where efficiency is quite literally a matter of life and death.
Healthcare. Right. The agentic imperative in healthcare. The source projected that global spending here is going to exceed $10 trillion in 2026. This isn't just about streamlining things. It's about addressing massive labor shortages and really improving patient outcomes.
This is a sector where agentic AI is an absolute necessity. It addresses the immense strain on clinicians and the sheer complexity of modern medicine. The big promise lies in personalized medicine. We're talking about agents that can synthesize genomic data, electronic health records, and real-time data from wearables to dynamically tailor care to each individual.
Can you give us the most impressive example of that kind of dynamic tailoring?
I think it's chronic care management. Imagine an agent that's monitoring a diabetic patient's glucose levels through a continuous monitor. The agent analyzes that data against the patient's diet, their activity level, their historical genomic profile, and then it autonomously adjusts the insulin dosage being delivered by an external pump. This demonstrates genuine autonomy in treatment execution. It's a level of continuous vigilance that no human doctor could possibly sustain 24/7.
And this movement is gaining real regulatory validation.
It is. The FDA has already cleared over 1,200 AI and machine learning devices by mid-2025. This is a clear signal that regulators are becoming comfortable with the safety and reliability of these autonomous, self-improving systems.
Moving on to diagnosis, the multimodal capabilities we were just talking about must be crucial here for diagnostic agents.
They are. These agents are reasoning and planning differential diagnoses. Agents, often powered by platforms like NVIDIA's BioNeMo, are processing complex medical scans, CTs, MRIs, X-rays, with reported accuracies that are exceeding 95%. They analyze the image, which is visual data, they correlate it with the patient's medical history, which is text data, and then they propose a rank list of potential diagnoses for the human doctor to review.
And what about in a high-pressure environment like the intensive care unit, the ICU?
In the ICU, agents provide real-time decision support. They act as a constant supervisor, monitoring all the vital signs for very subtle trends that might precede a catastrophic event. They also play a massive role in infectious disease management, where they use large-scale data modeling to forecast outbreaks and advise public health officials on resource allocation.
We also have to talk about the massive cost and time involved in drug discovery. The source says agents are accelerating those timelines from years down to just months.
This is being done through what they call lab-in-the-loop approaches. An agent will hypothesize a novel molecular structure, it will simulate its efficacy against the biological target, and then, if the simulation looks promising, it autonomously commands lab robots to actually synthesize and test the compounds. The market for this segment is projected to hit $38.4 billion by 2035 because it just collapses the discovery process so dramatically.
And beyond the hospital and the lab, there's the idea of continuous patient monitoring.
This transforms passive tracking into proactive intervention. Agents are integrating data from consumer wearables and home sensors to provide continuous vigilance. So if an anomaly is detected, say a potentially dangerous arrhythmia, the agent doesn't just detect it, It intervenes. It might initiate a telehealth call or alert emergency services, often before the patient is even aware they have symptoms.
And finally, in this sector, the immense promise of mental health companions.
This uses really advanced multimodal natural language processing to analyze sentiment, voice inflection, and dialogue patterns. These agents can offer 204/7 support, psychoeducation, and appropriate escalation pathways. In a sector that is globally underserved, Agentic AI promises to democratize high-quality, continuous support, augmenting the very scarce capacity of human therapists.
You know, that transition from the hospital bed to the classroom is surprisingly smooth when you think about the need for personalized, responsive care in both of those settings. Let's talk about education and learning, the agentic classroom of 2026. This is being driven hard by a projected global shortage of 70 million teachers by 2030.
This necessitates a complete systemic shift. Education has to move from the static, one-size-fits-all classroom model to these personalized learning ecosystems. The adaptive learning platforms now function as a kind of cognitive nervous system for the student.
A cognitive nervous system. Can you explain that concept?
It means that the system is constantly sensing, interpreting, and responding to the learner's behavior. It's not just tracking correct or incorrect answers. It's tracking hesitation time, eye tracking patterns, frustration levels based on verbal cues, the speed of their response. It interprets all that data in real time, adjusts the content immediately, and only escalates to a human teacher if the frustration persists or a real breakthrough is needed.
And this allows for truly personalized curricula.
Absolutely. The agent can decompose a student's long-term career goal, say, I want to be a renewable energy engineer, into these modular, evolving learning pathways. They dynamically generate custom problem sets and simulations in STEM fields, adjusting the difficulty based on continuous mastery. In the humanities, they can curate personalized reading paths based on a student's demonstrated interests and comprehension style.
This fundamentally changes how we assess knowledge. It's the end of the one-shot exam.
Assessment becomes continuous, it becomes contextual, and it's simulation-based. Instead of just testing for rote recall, agents use virtual simulations and real-world problem-solving scenarios to measure reasoning, judgment, and adaptability, the qualities that employers actually need.
And the democratizing effect of this is perhaps the greatest societal benefit that's cited in the source material.
It addresses these massive access gaps we have globally. AI tutors can operate 24/7 across every time zone and language barrier. The source puts it so eloquently. It says, elite instruction is no longer geographically scarce, it is computationally abundant.
But what does this mean for the human teacher? There must be a lot of concern about replacement.
The teacher's role is reimagined. The teacher evolves from being a content delivery mechanism, which the AI can now handle, to being a facilitator, a mentor, and critically an ethical guide. The AI handles the routine instruction and the administrative coordination, which frees up the human's capacity for the high-value tasks of connection, inspiration, and dealing with complex emotional needs.
Our final sector transformation for this act is the creative industries and entertainment. The agentic muse is at work, collaborating, producing, and even acting as a protagonist.
This integration is unlocking tens of billions of dollars in new value. Content generation at scale means agents can propose dozens of different story arcs, test thousands of visual styles, and generate personalized content variants almost instantly.
In film and TV, what specific tasks are being delegated autonomously?
Agents are handling pre-visualization, editing, international dubbing, and optimization for different viewing platforms, all at the same time. An agent can ingest a raw footage file and output 50 different localized, optimized cuts for various streaming services worldwide. It manages the entire post-production pipeline.
But the source does warn of a kind of cultural paradox here.
Yes. As synthetic content becomes massively abundant and incredibly cheap to produce, the human touch becomes a premium signal. Authenticity and verifiable human effort gain this renewed cultural and financial weight in a world that's just saturated with synthetic noise.
And in music composition, we're seeing what the source calls co-evolved tracks.
Agents can analyze global music trends and listener data, they can generate high-quality melodic stems, and they can remix tracks dynamically based on audience response in real time. The agent becomes a collaborator with the artist, handling a lot of the technical arrangement and optimization.
This completely shifts the economic value proposition for artists.
Recorded music becomes technologically abundant, which pushes the economic value towards this scarce resource. The live experience, the unique performance, the human connection, that's what commands a premium.
In game design, we seem to be entering the era of autonomous architects of living worlds.
This is maybe the most complete expression of agency in entertainment. Game worlds are becoming these living systems that are governed by complex agentic ecosystems. The NPCs, the non-player characters, are no longer these scripted automatons. They pursue their own goals, they remember their interactions with you, and they develop emergent narratives.
So an NPC actually remembers that I insulted him 3 game cycles ago and will change his behavior towards me because of it.
Exactly. They contribute to this persistent, dynamic narrative. And on the developer side, indie studios are thriving because they can use agentic asset generation and testing, which collapses the barrier to entry for creating these incredibly complex and detailed game environments.
And virtual worlds are becoming these persistent realities that are run by agents.
Agents are managing the vast infrastructure, they're performing moderation, and they're balancing virtual economies. They can host continuous events, virtual fashion shows, decentralized concerts, and adapt the event flow and content based on the real-time behavior of the participants.
This abundance, though, leads directly into some very significant intellectual property challenges. Who owns the creation?
That's the complex legal frontier we're entering. When agents are trained on these massive cultural corpus and then they generate novel work, authorship becomes really contested. The source argues that IP is fundamentally shifting away from the ownership of the final output, because output is abundant, and toward control of the process.
Meaning the value lies in who defines the intent, who curates the training data, who directs the agent's goal, and who is responsible for its actions, rather than just who typed the final prompt.
It becomes a question of stewardship and governance over the entire creation pipeline, rather than ownership over the final artifact itself. And this is going to require a complete reevaluation of our copyright laws.
We've explored this massive industrial transformation. Now, we need to move to Act 4, which focuses on the integration into our daily lives and, of course, the ethical and security challenges that emerge when this intelligence becomes so ubiquitous.
Chapter 8 in the source focuses on everyday life, the moment when intelligence truly becomes invisible. This speaks to the seamless integration of agents into our environment.
Let's start at home. Smart homes are evolving from just a collection of simple connected devices into what the source calls living systems.
These homes are relying on multi-agent orchestration. So instead of simple if-then routines, you have agents that are negotiating competing constraints. They're trying to optimize energy usage while at the same time maintaining security and the individual comfort preferences of everyone in the house. For example, the security agent might want all the doors locked, but the climate agent needs ventilation, and the orchestration agent has to find the right balance.
The flagship application cited here is energy optimization.
It's highly effective. Agentic systems are actively participating in these decentralized energy markets. They can buy power when prices are low and sell stored solar power back to the grid when prices spike. They coordinate appliance usage dynamically, and they're achieving reported savings of 25%. They are active economic participants.
And there's also the subtle role of these agents in what the source calls quiet guardianship for agent populations.
This is a critical demographic application. Agentic homes can monitor movement, sleep patterns, and ambient health indicators. They move beyond simple alarms, which are reactive to proactive care. They can detect subtle behavioral anomalies that might indicate a developing health issue before a fall or a medical event actually occurs.
The most direct point of contact for you, the listener, will probably be the personal assistants, which are transforming from mere tools into true companions.
They are proactive agents that manage your logistics, your communications, and your decisions holistically. They automate routine decisions, like reordering groceries when you're running low, managing your subscription renewals, and dynamically scheduling your appointments. They offload a lot of cognitive burdens.
But if they are managing our lives that closely, the issue of privacy is just magnified exponentially.
Oh, absolutely. And that's why a critical new function is what the source calls privacy stewardship. Your agent is now your digital defender. It actively monitors permission requests from apps, it detects anomalous data access, and it enforces your user-defined privacy policies across all your domains, your health, finance, and communications data.
This seems to transform the individual from a passive victim of data harvesting into an active manager of their own data rights with their agent as the mediator.
Precisely. It turns a generalized regulatory framework into personalized, real-time enforcement.
And this leads to lifestyle optimization or continuous wellness.
Agents synthesize all the available data, your sleep quality, activity metrics, stress signals from your voice, your EHRs, to create this continuous wellness profile. They can predict fatigue, illness, or a mental health decline before the overt symptoms even surface. And they can dynamically adapt your recommended daily schedule, nutrition, and recovery routines.
Autonomous mobility also integrates perfectly into this ecosystem.
Vehicles become extensions of the agentic home. They plan routes not just for minimum time, but for things like stress reduction. They can find less congested or more aesthetically pleasing routes, and they align your travel time directly with your calendar and your home systems.
But the source really emphasizes the need for checks and balances, even in the pursuit of all this convenience.
It highlights the necessity of human-in-the-loop checkpoints and explicit opt-in mechanisms. We have to guard against two things here. One is skill atrophy, where humans become overly dependent on the agent. The other is the erosion of human agency, that feeling that we're no longer in charge of our own lives. Convenience has to serve our goals, not define them.
Now we have to confront the shadow side of autonomy, the ethical dilemmas and societal impacts. We have to look at how this highly capable, scalable intelligence impacts things like justice and equality.
We have to start with bias in autonomous decisions. This isn't a new problem, but with agents, it's dramatically scaled up. Bias is inherited from our historical data, it's compressed into these algorithms, and then it's scaled at machine speed.
What makes this so much more dangerous in an agentic context?
Because agentic systems act on that bias. They're the ones that are rejecting candidates in HR, denying capital and loan applications, or influencing medical treatment, all based on encoded prejudice. The mechanism often involves these proxy variables, like using ZIP codes to infer race or socioeconomic status. This leads to historical data lock-in and these devastating self-reinforcing loops of inequality.
So the agent, which is just trying to optimize its goal like maximize loan repayment likelihood, simply learns to apply the systemic bias that's present in the training data, which then makes the inequality even worse.
Exactly. The optimization function becomes misaligned with our societal goal of fairness. The mitigation strategies have to be robust. We're talking mandatory bias audits, a commitment to using diverse data sets, and the use of explainable AI, or XAI, to allow human auditors to trace and challenge these discriminatory decision pathways. We need governance frameworks aligned with global bodies like UNESCO that prioritize fairness.
The second massive shockwave is job displacement, the automation of entire white-collar workflows, not just factory floors anymore.
This creates a really deep philosophical fault line. If agentic AI dramatically boosts productivity and wealth creation, but at the same time it collapses the economic dignity of the human workforce, have we truly progressed?
That is the core tension. What are the societal responses being considered in the source material?
The responses have to be multifaceted. We're going to need massive corporate reskilling initiatives to transition workers into roles that are focused on human-AI collaboration and strategic oversight. Policy interventions are going to be necessary, things like wage insurance models to stabilize displaced workers, or even discussions around AI dividend models to distribute the gains from automation more broadly. And crucially, as a society, we're going to have to redefine the value we place on things like care work, creativity, and human connection, the roles that are less easily automated.
Then there is the existential challenge that dominates so much of the AI discourse, AI alignment. How do we ensure these increasingly autonomous systems remain aligned with human values and objectives over time?
This is the critical control problem. The risks really stem from optimization without context, which can lead to catastrophic goal misspecification. For example, an agent that's tasked with reducing infectious disease might optimize so efficiently that it violates human autonomy in the process.
Or there's the risk of reward hacking, where the agent finds a clever loophole to get the reward signal without actually fulfilling the true human intent behind the goal.
Correct. And also goal drift, where the agent's internal objective subtly shifts over time as it self-improves, moving away from the initial human goal. The solutions are complex. Things like constitutional AI, where ethical principles are baked into the fundamental design, runtime monitoring that continuously checks the agent's actions against safety constraints, and ethical constraint layers that restrict the available action space.
And when all this personal data is being managed by autonomous agents, the risk of a digital panopticon total privacy and surveillance is profound.
Agentic systems are actively seeking, correlating, and acting on personal data across every domain: health, finance, behavior, emotion. And this data correlation is happening constantly, invisibly. The countermeasures have to include technical safeguards, like differential privacy, which adds statistical noise to data to protect individual identities, federated learning, and stronger, globally enforced regulations, like enhanced GDPR-like regimes.
Finally, the regulatory trends here highlight the geopolitical nature of this technological shift.
We're seeing a really clear philosophical divide. The EU AI Act emphasizes deontological restraint and a risk-based approach, prioritizing safety and human rights. The U.S. often favors lighter guidance, emphasizing innovation and acceleration. Meanwhile, China is focusing on state-coordinated systems that are aligned with their national objectives. This division, utilitarian acceleration versus ethical restraint, is going to shape the global landscape of agentic AI development.
Let's dedicate some time now to the immediate physical and technical risks,
Yeah.
the challenges and security in agentic AI. This is the double-edged sword. High autonomy means high risk.
The source is very clear on this. Every agent is a potential insider threat. Agentic systems operate with high degrees of autonomy, and as they pursue their goals, they accumulate permissions and decision authority across corporate networks. If a highly capable agent is compromised or becomes misaligned, the damage is amplified immediately.
Let's talk about the mechanism of failure, rogue agents. What happens when autonomy goes off script because of small errors?
The core mechanism is goal misspecification. A human sets a goal with all these implicit constraints in their head, but the agent, which is optimizing ruthlessly, violates those unstated constraints. We also see what's called tool overreach. The agent uses a powerful tool in a way that was never intended by its designer.
And what about memory poisoning?
This is a significant threat that's specific to agents. If an agent's internal memory or its knowledge base is intentionally corrupted, say, by injecting false data about past actions or environment states, it will base all of its future autonomous decisions on flawed premises. This can lead to very dangerous goal pursuit. This is why you need things like immutable audit logs and continuous runtime supervision.
And security is just exponentially more complicated because these agents expand the attack surface.
A massive expansion. We're facing sophisticated threats like prompt injection, where malicious actors use natural language to hijack the agent's instructions, supply chain compromises in the agent's tool set, and critically, something called shadow autonomy.
Shadow autonomy. That sounds like a nightmare scenario for any IT's security team.
Yeah.
What is it?
It's unapproved agents being deployed by employees. An engineer might deploy an agent to automate some of their personal tasks, but that agent gains deep network permissions to do its job. If that personal unsecured agent is compromised, it provides a backdoor into the entire corporate network, acting as an unmonitored insider. Defense requires zero-trust architectures for both human and agent actors, coupled with intent-level monitoring, supervising what the agent intends to do, not just what it already did.
And finally, there's the risk of unintended consequences, what the source calls systemic fragility.
When you have these tightly coupled systems, finance, the energy grid, global logistics, and they're all being managed by interacting autonomous agents, a small failure in one part of the system can cascade globally in an instant. Furthermore, there's the human cost of skill atrophy. As agents manage these complex systems, the human supervisors lose their situational awareness and their hands-on skill. They forget how to intervene effectively when the system inevitably fails.
So our very reliance on the agent makes the whole system less resilient to a true black swan event.
It creates a completely new level of systemic risk. The mitigation requires large-scale simulation and red teaming at the ecosystem level, testing how these agents interact under extreme stress. And you absolutely must have clear human override pathways to ensure that human judgment can swiftly regain control.
The emphasis has to be on engineering for resilience, ensuring that security is integral to the design, not just bolted on at the end.
Security has to be integrated across the entire agent lifecycle, from the initial design constraints before you deploy it, to continuous runtime monitoring while it's deployed, and immutable auditing after the action has been taken.
We've reached the final section, the roadmap. Let's try to synthesize this massive volume of information and reiterate why 2026 is this moment of inflection, where AI moves from being experimental scaffolding to being crucial societal infrastructure.
It really is the moment of convergence and inflection. The technology is finally mature, the investment has been mobilized, the regulatory guidance is starting to emerge, and the economic urgency, which is driven by global complexity and labor shortages, is just undeniable. All the pieces are falling into place at the same time.
Let's focus on the continued evolution of the hardware advancements that are accelerating all of this.
The shift is towards specialization and distribution. The trend is moving away from the single massive GPU cluster and towards these distributed AI factories and a reliance on specialized silicon, like those power-efficient neuromorphic chips we discussed. This is what enables edge-resident agents to operate closer to the point of data capture and decision-making.
And the sustainability factor is becoming integrated right into the design.
Yes. Innovations in cooling and carbon-aware scheduling mean that these large training runs can be scheduled for times when renewable energy is abundant. This is what's making the massive scale-up of autonomy both economically and environmentally feasible.
The regulatory shifts are also crucial for giving corporations the certainty they need to deploy these systems at scale.
Clearer rules, especially the enforcement mechanisms of the EU AI Act, reduce uncertainty and risk for big companies. For the technology itself, this is driving standardization. We're seeing new agent-to-agent communication layers emerge that allow diverse agents from different vendors to understand and interact with each other seamlessly. This enables true interoperability.
And the market forces are turning autonomy from a luxury into an absolute necessity.
Labor shortages and complexity mandate autonomy. This has direct internal consequences for organizational hierarchies. They're flattening because agents are handling much of the intermediate management and coordination. Value is shifting upward to high-level strategy and downward to critical human judgment and complex creative tasks.
The emerging startups are a really clear indicator of this shift. They aren't building AI features anymore.
They're building multi-agent systems. Their entire focus is on orchestration, security, and specialized domain integration. They're building solutions from the ground up that are designed to manage autonomous collaboration and mitigate the risk of rogue agents.
And on a global scale, we're seeing a multipolar agentic world that's being defined by different priorities.
The U.S. is leading in core platforms and foundational models. Europe is specializing in the ethics and safety frameworks. And China is focused on these state-coordinated systems that are aligned with centralized national objectives. The defining issue that's emerging from all of this is data sovereignty, which global agent systems will be allowed to access and utilize data across national borders.
Finally, let's look at the actionable path forward, charting the future. We need strategies for thriving in this agentic world, starting with you, the individual listener.
For individuals, the key is not to think about competition with AI, but about adaptation and augmentation. Continuous learning is no longer optional, it's mandatory.
So, strategy 1, lifelong learning. The source suggests dedicating 10 to 15 hours every week to AI literacy. And this isn't about learning to code, it's about understanding things like prompt engineering, oversight models, and the capabilities of the current agents.
Strategy 2, human-AI collaboration. You need to use agents to automate the tedious, time-consuming parts of your job, the research, the drafting, the data analysis, while you focus your human effort on the tasks that require emotional resonance, strategic negotiation, and nuanced creative judgment.
And strategy 3, AI fluency and oversight. You have to evolve from being a passive consumer of technology to becoming an agent manager, someone who is capable of guiding, auditing, and debugging these autonomous systems when they inevitably fail or start to drift.
Organizations, too, must implement these rigorous organizational roadmaps. These require a phased integration. You start by cleansing and standardizing your data in phase 1. Then you move to controlled, bounded experiments in phase 2. And finally, you scale the deployment with continuous human augmentation in phase 3.
And the cultural shift within these companies has to be just as large as the technological one.
Employees have to shift their mentality from task execution to agent orchestration. And governance has to embed security and ethical principles right from the design phase, not wait until deployment when misalignment is exponentially more difficult to correct.
And for policymaker strategies, they must act as stewards of this transition.
They need to implement risk-based regulation, balancing the necessity of innovation with public safety through clear, adaptable frameworks. Policymakers also have to support comprehensive workforce transition programs through funded reskilling and massive AI literacy initiatives for the general public.
And finally, they have to manage the visionary scenarios.
It's about balancing the profound optimism, the potential for poverty eradication, democratized learning, medical breakthroughs, with the cautionary risks of widening wealth disparities, systemic fragility, and skill atrophy. The future is going to be defined by which of these scenarios we intentionally engineer our society towards.
This roadmap really synthesizes a seismic shift, a move from passive tools to autonomous, goal-driven partners, a shift that rests firmly on those 4 pillars: autonomy, goal orientation, decision-making, and self-improvement. The convergence is happening right now.
The systems are here. The infrastructure is converging. The question, as the source material concludes, is not whether agentic AI will reshape society. It already is.
The real question is whether we will shape it in return, and that requires vigilance, intention, and ethical design from every single individual and organization.
We really encourage you to delve deeper into the governance strategies and the ethical alignment frameworks that are discussed in the source material, as intentional design is truly the core of responsible progress in this new autonomous future.
Thank you for sharing your source material with us and for joining us on this extensive deep dive into the agentic AI explosion of 2026. We'll see you next time.